I want to do a brief trig review with some of you because we're going to be using this for a concept we need in physics and for calculations you're going to do today. We're going to define two, I guess I'll call them functions, and I'll just tell you how to calculate them. The first function is called the sine of this angle theta here. And all you do to calculate it is you take this side of the triangle, the opposite side, and divide it by the hypotenuse, and whatever that number is, that's the sine of the angle. To get the cosine of an angle, you take the adjacent and divide it by the hypotenuse. This is letter A here, this length here. There is actually a third quantity called tangent, which we may use sometimes, which is the opposite over the adjacent. That's this side over this side. And there's actually a little mnemonic we use to memorize this called SOHCAHTOA. Now I'm going to use this fact on the next page to actually do some math that we're going to need for the physics class. So this is what we call a vector. It is an object that has both magnitude and direction. And the way this works is you draw a line with a certain length, and you can even measure the angle that it's at. Now I want to calculate two parts of this vector that we use in physics. We call these parts components, and they're like the invisible legs of the triangle that they complete. So if I take this SOHCAHTOA idea from the previous page, I know that the opposite over the hypotenuse is the sine. So if I want to get the length of this opposite side, I could take the hypotenuse times the sine of theta. So if I have the length of this vector here, and I'll call that length v, if I take v times the sine of this angle theta, that gives me the length of this leg here. We call this the y component of the vector. To get the x component, we do something similar. We're going to take v times the cosine of the angle. Now it turns out your calculator can calculate cosines and sines of angles very easily. Let's actually apply this to a problem. So for example, suppose I have, I'll say, a vector with a size of 3 pointing at 30 degrees. And I say get the components. So I want to know the length of this leg and this leg of the vector. Remember, this is the y component and this is the x component. To get the y component, I'll take 3 times the sine of 30. And when I put that in my calculator, I'm going to get 1.5. So make sure your calculator is in degrees. The next thing, if I want to get Vx, that's going to be 3 times the cosine of 30. And that's going to work out to 2.6. So that's a quick introduction to calculating vector components. And what I want you guys to do today is to actually complete all the vector components on these worksheets, because we're going to do a little treasure hunt when I get back from Kairos.